This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, one administrative note. Last Wednesday's lecture, for whatever reason, the audio recorded but not the video. So I sent a ticket to IT, and you can see the estimated completion is March 11th. So I should hear this week. Hopefully this is not going to be a problem today. I mean, this is out of my control. I have no idea what goes on. Because we had the same setup as Monday, and Monday's lecture worked fine. So I don't know. You can see the video, so it's connected, it's running, but for some reason it didn't record. So hopefully they'll get back to me by Wednesday or whatever. But hopefully it'll work today, like it'll work last Monday. Maybe it just doesn't like Wednesdays, I don't know. Okay, so anyways, we'll let you know about what happens there. So check the recording afterwards. Hopefully it'll work today. I don't know what the issue is. Okay, I want to mention a few things from the Consumer Choice 1 lectures that we ended up on last week. So we finished up with preferences. I just want to mention a few things about the utility function. In fact, before I do that, let me just talk briefly about concave and convex functions, since I was asked a few questions about that. Okay, so just briefly, in case you're wondering, when I talk about a concave function, think of like a parabola y equals x squared. Y equals minus x squared. Okay. Notice if you take any 2 points on that function and draw a straight line between them, all the points on the line between them lie strictly below the function. So that makes it a strictly concave function. Conversely, so that's strictly concave. Conversely, a strictly convex function just says something like y equals x squared, the parabola. You take any 2 points on that function, draw a straight line between them, all the points in between lie strictly above the function. Right? So that's what we mean by strictly convex, strictly concave. And then we say, well, we also have a distinction between strictly convex and convex, and strictly concave and concave. The only difference is, if you have a concave, but not strictly concave, something like the following. Draw 3 line segments that look like this, where the slope keeps decreasing. Notice if you take some points between, maybe I'll use a different color here. If you take these 2 points, and draw a straight line between them. Maybe that's why I didn't use that color. Okay. And draw a straight line between them. Notice all the points on the line between those 2 points lie strictly below. And you may say, well, therefore it's strictly concave. But if you take these 2 points on the same line segment, notice that the points in between lie exactly on the function. Right? So it's not strictly concave. To be strictly concave, for any 2 points you pick has to be strictly below the function. These, you pick any 2 points on this function, It's on either below or on the function. So we say it's concave, but not strictly concave, right? And you can do the same thing for convex, but not strictly convex, right? This is convex, but not strictly convex, right? For example, if you take these 2 points here and draw a straight line between them, all the points between them, they're on the function, not above it, right? But if you take any 2 points on that function, it's either on the function or above it. So we say it's a convex function, but it's not a strictly convex function. Okay? So just to let you know the distinction when I talk about concave, convex, or strictly concave, strictly convex. The nice one to have for us is strictly convex indifference curves. As we're going to see, that makes our life simpler. But there's no particular reason it has to be strictly convex, other than it makes our life easier, so we tend to assume it. Okay? Any questions about that? Does that make sense? Now you can do it mathematically, you know, let t be a parameter between 0 and 1. Take any 2 points on the function, x and x prime. Go t times x plus 1 minus t times x prime. That's the line between those 2 points when t is between 0 and 1. And then you take the value of the function at that point, tx plus 1 minus t times x prime. And that value of that function must be higher than the value of the line. Okay, anyways, don't worry about that. Okay, I just wanted to let you know what I meant by convex and strictly convex, concave and strictly concave. All right. Let's go back to regularly scheduled programming. Oh, or not. Okay, I want to talk about the utility function, and I didn't actually show you the utility function again last week, so I thought I'd show you an example. This is a typical utility function. Now, by looking at it, you should get a feel for this already, right? So, on the base, in the one dimension we have quantity good 1, in the other dimension we have quantity good 2. Notice they're all non-negative, so a constraint that the quantities have to be non-negative. So those are northeast quadrants in the base there. That's all the possible bundles that we're looking at, right? 40 units of good 1 and 50 units of good 2 will be somewhere over here, and so on and so forth. Right, so those are all the combinations. And then the height, the third dimension, gives us a utility. So we pick bundle 40-50, 40 units of good 1, 50 units of good 2, somewhere over here. That point there, the height of the curve, would be the utility of the bundle 40-50. Now look at this utility function. Notice that if you hold y constant, good 2 constant, say at 50 units for good 2, and change the amount of good 1, what happens? As you increase good 1, notice that the utility function gets higher and higher. Okay? So what is that telling you? It's telling you that more is better, right? If you like more good 1. If I give you more good 1, and keep the amount of good 2 constant, you're happier, right? So that's what it's telling you. More is better tells you the increase in that direction for good 1. Likewise for good 2, if you hold a good 1 constant, say at 40, and increase the quantity of good 2, you're also going up. So more good 2 is better, right? So we satisfy monotonicity here. You can see the monotonicity is in there. Now mathematically, we would express that by saying that the marginal utilities are positive. Remember, marginal utility is the partial derivative of utility with respect to the quantity of the good. So the marginal utility of good 1 is the derivative of utility with respect to x1 holding x2 constant, right? The partial derivative, which is exactly what we saw going in that direction. That's positive, saying more of the good is better, right? If you have more x1, your utility goes up. So the derivative is positive. And likewise, for marginal utility of good 2 is also positive. So you can see that in the diagram just by looking at it. The other thing you can see is this is a concave function. Take any 2 points on this function, draw a straight line between them, and can you see that they're going to be below the function? Right? So that's what makes this a concave function in 2 dimensions, rather than just the 1 dimension that I did on the notebook. Okay? So this utility function, in fact, is strictly concave, which is a typical one that we're going to use. Right? More is better, so it's going up. and it's concave, so if you take any 2 points, any 2 utilities, draw a straight line between them, right? Then the line is going to lie underneath this utility function. Okay, so that's a strictly concave. That's one to give you a feel for this. So what I did is I said, okay, let's find out all the combinations of good 1, good 2, that is all the bundles that had the same utility, right? So if we had the same utility, that means all the combinations of x and x1, x2, all the bundles that had the same height, right? Same utility. Okay. But remember, that's what we call an indifference curve. All the bundles that have the same utility, right, equally happy, we call that an indifference curve. So if you can see that in geography, they call this a contour line. You might call it a level set if you've seen it in a different context. All the same thing. But if you can see all the combinations of good 1 and good 2 that give you the same utility, it may be hard to see, but the same level will actually be a curve, and that's what I showed you last. Oh, I forgot about this one. This is what the actual Cobb-Douglas utility function we use looks like. It's not as clear as the previous one, which is why I gave you the previous one, but it's still the same situation, right? One dimension is good 1, the other dimension is good 2, and if you have more, you're going up higher utility, okay? And it's also concave, right? It's looking something like that. That's a little bit harder to see there. Anyways, so we take all the combinations of x1 and x2, sorry, x and y in this case, x and y, they had the same utility, so they had the same height. And that's maybe hard to tell here, but that's actually a curve, and that's what I showed you last week. So those are all the bundles on the base here, all the bundles that had the same height, that is the same utility. Right? So that's these bundles, all these bundles on the base, that's your indifference curve. They all give you the same utility. Okay? Now I rotated the axis so that you could see the curve a bit clearer here. Right? I just wanted to make sure it's clear. So what we usually do, so notice by the way, we have a concave utility function, but the indifference curve that we get from that, notice the curve in it, the indifference curve are convex. Right? If you take any 2 points on this indifference curve, draw a straight line between them, all the points on the line between them lie above the indifference curve. In fact, it's not only convex, this example, Cobb-Douglas, is strictly convex, which turns out to be very useful to work with, as we're going to see this week. Okay? So just to give you a feel for the utility functions of the difference curve. So that indifference curve just came from the utility function. Right? All the bundles, x and y, that had the same utility, that is, that had the same height. It's as if we're looking down from above, right, onto that base, all the combinations of x and y that have the same height, utility equals 30. Okay? So hopefully that gives you a bit of a feel for this. Okay. What else did I put in here? Oh yeah, one other thing I want to put in there. So I said that, notice that all three of these indifference curves are actually convex indifference curves. Right? Start off with the Cobb-Douglas. Take any 2 points as we said on the green curve. Draw a straight line between them. All those points in between lie above the indifference curve. So it's actually a strictly convex indifference curve. You can do that for any 2 points on that green curve. Right, so Cobb-Douglas is a strictly convex indifference curve. But the other two are convex but not strictly convex. Can you see that? Let's do with the perfect complements one. Right? If I pick a bundle on the horizontal component and another bundle on the vertical component, draw a straight line between them, all the points on the straight line between them lie above it, so you might say, oh, that means it's strictly convex. This has got to be true for any 2 points. If I pick 2 points on the horizontal segment, draw a straight line between them, notice that they're on the indifference curve. Likewise, if I pick any 2 points on the vertical segment, draw a straight line between them, all the points on the line between them are on the indifference curve. So if for any 2 points on this blue indifference curve, it's the case that if you draw a straight line between any of those 2 points, they're always going to be either on or above the curve. So therefore it's convex, but it's not strictly convex here. Likewise, the perfect substitute, a linear line, straight line is convex by definition. That is, if you take any 2 points on the straight line, draw a line between them, it's the same line. So all the points between those two bundles will be on the line, not above it, exactly on it, That's on or above, so it's convex, but it's not above, so it's not strictly convex. Right? Notice, by the way, that the linear function is the only one that's both convex and concave. Right? Because it's on or above, it's also on or below. So, by definition, it's a convex and concave function. That's the only one that is. Okay? So don't get too caught up, and I just want to let you know when I talk about convex and concave functions. So we like to have convex functions, right? They work nicely, as we'll see. I'll show you some examples of like the chamber of horrors when we have a concave function. Okay? Yeah, thing I want to add here, by the way, is notice we have three different utility functions. Remember, utility functions is simply a numerical representation of our difference curves. So these are the difference curves, but we can attach numbers to them, right, with a utility function. So we have three different utility functions here. But it turns out in economics we can use one function to represent all three of these different types. We have a family of utility functions called the CES utility function. If you're interested, CES stands for constant elasticity of substitution. Now, we haven't talked about the elasticity of substitution, so don't worry about it. But as you might guess, it's a constant. Okay? Anyways, what this function looks like is it's a whole family of functions that vary according to this parameter rho. Rho is just a Greek letter. It looks like a P, but it's slanted a bit. Okay? So here's the CES utility function example of it. You take the amount of x raised to the power of rho plus the amount of y raised to the power of rho, add them together, and then raise that whole thing to the power of 1 over rho. That's a CES utility function. Why is that useful? Well, for example, imagine that rho is equal to 1. What's this equal to? Well, rho is equal to 1. This is just x plus y. Right? So that's our perfect substitutes utility function. Now, it turns out as if rho goes to minus infinity, then the CES approximates the perfect complement utility function. And I give you an example here. I said rho equals minus 50. If you put rho equals minus 50 into your math program, you'll see it looks like this. Very much like the perfect complements. The only difference being we smoothed out the kink. Instead of being completely, vertical and then horizontal, it rounds out a little bit here. Okay? And then finally, if you set rho close to 0, the closer to 0, then the closer it looks like a Cobb-Douglas function. So it's a very useful function to have. You don't have to say a priori, I'm going to assume that the perfect substitutes or perfect complements are somewhere between with the Cobb-Douglas. You can just vary the parameter rho and let it be any of those three. Okay? So I just want to show you that that's possible. Okay. Any questions? Okay. I will repost a complete version of the lecture notes to put this one up so you can have this as well. Okay? But I thought you might be interested in seeing this. Okay. So CES is much more useful. We tend to use Cobb-Douglas because it's so easy in class, but CES is more general. In fact, we can even make the CES function more general. Notice I said this is an example of one thing to make it more general is we can change the weights of the two terms in the bracket. We can attach a weight of alpha to the first term and 1 minus alpha to the second. And by varying alpha, that means we can put more weight on x and less on y, or vice versa. So that's, again, makes it more general. But anyways, so that's the idea of CES. It allows you to have much more flexibility on what the utility function looks like, all the way from perfect substitutes to perfect complements and everything in between. Okay? So I will post that, I guess, tonight. Okay. So make sure we understand what's going on here. So we said what we're interested in deriving the demand curve. And we said the demand curve is determined by the choices made by consumers. And we said there's two things that matter for what the consumer chooses. One is their taste, which we just done. Right? We represent their taste by the preferences to indifference curves. So visually it's the indifference curves. Mathematically or algebraically, it's the utility function. It's the same thing. Right? So we got that side of the equation, what they like. We can represent that with the indifference curves or utility function. Now the other side of the equation is not just what they like, but what can they also afford. Right? It's nice to say, well, I'd like to drive a Ferrari, but if you can't afford a Ferrari, then you won't be able to choose that. Right? So it's a combination of what you like and what you can afford that determines what you're going to choose. Okay? So in this lecture slides, we're going to look at what you can afford. Now, as opposed to the preference lecture notes, this is much more straightforward. I think you'll find this pretty basic. Okay? As we'll see. Okay. So remember, when we set for preferences, they're independent of your income or your prices. Right? You don't like something because it's expensive, right? Or you don't like something because it's cheap, right? That's just whatever you like is what you like. Now we're going to introduce account for income and prices on how that affects your decision of what you choose. Okay. So you can only choose what you can afford. No matter how much you like something, if you can't afford it, you can't choose it. So we want to see what determines which bundles are affordable. Well, there's two things that are going to determine that, in the usual case anyways, and that are the prices of the goods. So I made a vector of prices from P1 to Pn if there's n goods. But typically we'll do two goods, so it'll be P1, P2. Right? And it's going to be your budget, which will use capital M like it stands for money. Right? Although we'll often refer to it as income, but I will make the distinction in a second. But I will say income. Although strictly speaking, it's your budget. Okay? So let me just mention about this. So often students first see this, they get a bit confused. They'll say, we're using our income to buy these two goods. What if I want to save some of my income? That's typically what you do, right? You save some of your income, right? So you don't spend all your money on the two goods, is what we're going to assume. Okay, that's fine. And suppose you had $100 and you want to save 20, then that means you only have 80 left over. Well, that's what our aim is going to be, the 80 left over. That's your budget to spend on say, movies and pizza. Okay? So you've already made the savings decision, and now whatever's left over, that's your budget, but we're going to be lazy and call it your income. Okay? So when you think about making a decision, M, we're going to call it income, but it's just your budget, whatever you have available to spend on the goods. Okay? Now this is not a real problem, by the way, because it turns out we can also model the choice about how much you want to save. If you think about it, why are you saving? You're saving so that in the future you can consume more, right? So really, the choice of saving comes down between a choice of either consuming now or consuming more later, right? If you consume less now, you save more, which allows you to consume more in the future. So the way that economists will model this, if you're worried about the savings decision, is we'll call one good consumption today, and the second good we'll call consumption tomorrow, right? And the decision is how much you want to consume today versus tomorrow, right? The less you consume today, the more you have to be able to consume tomorrow from your savings, right? We introduce an interest rate, so that you can, if you save $100 today, the interest rate is 10%, you have $110 more consumption tomorrow, okay? So we can model this. We call this intertemporal, between times, intertemporal choice, okay? So that decision's already been made. We already decided how much we want to spend today, how much we want to spend tomorrow. We can model that. We do that a lot, right? That intertemporal choice. So we have that, and we say, okay, now we want to save $20 for the future. We made that decision, and now we have $80 left over. That's our budget, okay? So don't get caught up on the savings part. We've already made that decision before we get to here now, okay? We've made a decision. We're going to save 20 of 100. We're going to spend the remaining 80 on these goods. Okay. Okay. We call the set of affordable bundles the affordable set or the budget set. Now, budget set is much more common, so I'm going to use that, although maybe affordable set is a better, clearer definition. So the budget set are all the affordable bundles. These are the things that we can afford to buy. Okay. Let's see what they look like. So I'll do an example here. Suppose the movies cost $15, so PM equals 15. Pizzas cost $5, so PP equals 5. And your income is $60, or if you want to say your budget is $60, right? So we're going to call it income. Okay, so you have $60 available to spend that month on pizzas and movies, and those are the places. So this is a typical situation. We give you this data, right? The consumer doesn't choose these places, right? They just take this as given. In fact, we're going to take the income as given. They've already made the decision on how much they're worth. So the income is already determined before we get here. Okay? So the income is whatever it is. All right? Now you have that income, you have the $60 to spend this month. How are you going to allocate that $60? How much to movies, how much to pizzas? That's the decision we want to make. Okay. Now let's take a look at this. What are all the affordable bundles? What are all the bundles that you can afford? Combinations of movies and pizzas that you can buy with your $60. Okay? If you spent all your income on movies, how many movies could you buy? Well, you have $60, movies cost $15, so if you spend all your money on movies, you could buy 4 movies. Or watch 4 movies. I guess you could rent them. Right? Likewise, if you spend all your income, all your money on pizzas, how many pizzas could you eat? Well, you have $60, pizzas cost $5, so you could have 12 pizzas. Now note, we call this 4 and 12 the real income of the consumer in terms of movies and pizzas respectively. What do we mean by that? Well, the M equals 60, we call that your nominal income. Nominal means that it's your income that's as expressed in the currency you're using. So here we're using dollars. So this is your income in terms of dollars, the currency you're using. Real income is measured not in currency, but in terms of goods. That's what makes it real, right? It's the actual goods. That's ultimately why you want to have income, is so you can have goods and services. Right? That's why you're working, so you can have goods and services to spend your money on. Right? If you're having income and you can't spend it on anything, it's sort of useless. It does nothing for you. Okay, so this is your real income. In terms of movies, right, your $60 is worth 4 movies. Because $60 can get 4 movies. So your real income in terms of movies is 4. You could buy 4 movies. Likewise, your $60 in income can get you 12 pizzas. So that's your real income in terms of a good pizza. Right? Your income is worth 12 pizzas. Okay? To an economist, this is what matters. Right? Your normal income doesn't matter. That can fluctuate. Right? Whereas your real income tells you how well off you really are. So for example, suppose the price of movies and pizzas double. Right? You still have the same nominal income of 60. Well, notice that your nominal income hasn't changed, it's still 60. However, your real income has changed. You have $60, if you bought all pizzas, now pizzas cost $30, so now you can only buy 2. So movies cost $30, so now you can only buy 2 movies. Likewise, pizzas doubled, they cost $10. If you spent all your money on pizzas, now you can only get 6 pizzas. Right? So notice that your real income went down. You're actually worse off, even though your nominal income didn't change. So that's why this is what matters more than your nominal income. We want to look at your real income. What's your real bargaining power? How much can you actually consume with your income? That's what real income tells us. Okay. So we found out some bundles that you can afford. You could buy 4 movies and no pizzas. You could buy 12 no movies and 12 pizzas. Right? So those are 2 bundles that are affordable. That is, they're in your budget set. Right? But there are other combinations, obviously. You don't have to buy all of one or all of the other. Right? If you can spend your $60, if you bought one movie or watch one movie, it cost you $15. You have $45 left over. So how many pizzas can you get? Well, pizzas are $5. So that means you can buy 9 pizzas. Right? So therefore, the bundle 1.9 is affordable. Therefore, it's in our budget set. And you can do the other ones. 2 movies are going to cost you $30. That leaves you $30 to spend on pizzas. Pizzas $5 each. That means you can buy 6 pizzas. That means the bundle 2.6 is affordable. cost you $60, right? Likewise, 3 movies is going to cost you $45. That leaves you $15 to buy pizzas. So you can buy 3 pizzas. So the bundle 3 is also in your budget set. Okay? So those are all affordable combinations. But of course, if you wanted, you could choose to spend less than your budget. Now, this is, be careful about here. You're spending less than your budget. You're not saving it. You're just not spending it. You're throwing it away. Okay? We've already done the savings decision. You've already put your $20 in the bank. You have $80 left. Right? If you don't spend that $80, it burns up at the end of the day. Okay? It just goes. Right? But you could choose to spend less than your budget, less than your $60. Okay? So, for example, you could buy 2 movies and 2 pizzas. 2 movies will cost you $30. 2 pizzas will cost you $10. You spend $40 and you just waste the other $20. You wake up the next day and say, oh, you know, I had a coupon for $20 for pizzas and movies, but it expired yesterday. I have to throw it away. Okay? It's gone. It's not saved anything. You just didn't spend it. Okay? All right. So those will be affordable. Anything you spend less than $60 is also affordable, and therefore it's going to be in your budget set. All right. So what is your budget set going to look like? Like I said, this part's pretty straightforward. So we saw that you could afford to consume this bundle 012, or 19, or 26, or 33, or 40. So those are all in your budget set. And remember, we make the assumption that we're allowing fractional consumption. So it's not hard to see that anything in between is also in your budget set. Right? So 1 month you consume 2 movies and 6 pizzas. Next month you consume 3 movies and 3 pizzas. On average, you're consuming 2.5 movies and 4.5 pizzas. So that'll be affordable too if you multiply it over the prices. It adds up to $60. All right? So anything on that line will also be affordable. But anything below will also be affordable because you'll be spending less than your income. All right? So there's our budget set. These are all of the affordable bundles given your income and given the prices of the goods. The idea is you can choose anywhere in this purple set here, right, this triangle area. You could choose to consume no movies, 12 pizzas, 1 movie, 9 pizzas, 2 movies, 2 pizzas, whatever. All of those are affordable. Now notice again, anything that lies below this line is affordable, but you actually spend less than all your income, all of your budget. You're just throwing away the remainder. You're not saving it. You're just throwing it away. All right. Now, we call that the budget set, all the set of affordable bundles. That line, top here, we call that the budget line. The budget line, all the bundles they use exactly add up to your income. Right? You spend your entire budget. Right? So all of these ones, remember, all these bundles cost $60. So they're on your budget line. And then anything in between, any of those fractions also count. All right? So that's our budget line. Right? All the combinations, all the bundles that you spend all of your money, all of your budget. Okay? Now, I'm going to get ahead of myself just slightly here. In the next lecture slide, we're going to say what the quote we're going to choose. And the answer is, the consumer wants to choose among all the affordable bundles, the one that's most preferred. That makes sense, right? Well, if we assume monotonicity, it turns out, oh, I forgot to put this in right, the intercepts. I forgot to notice the intercepts, so let me notice them. What's the horizontal intercept? 4 movies. Well, we saw 4 movies before. What was it? That was your real income in terms of movies. Right? If you spent all of your income on movies, you could buy 4 movies. So the horizontal intercept of the budget line is your income divided by the price of movies. In other words, your real income in terms of movies. Likewise, the vertical intercept is 12 pizzas. We saw that that's your real income in terms of pizza. That is, take your income M divided by the price of pizzas, 60 divided by 5 is 12. That gives you your vertical intercept. Right? So like I said, this part is pretty straightforward. I mean, how easy can you get with such a straight line? Right? So you have a horizontal intercept, you have a vertical intercept, and then you're going to have a slope we're going to look at in between. Can't get much easier than that to look at. So like I said, this part's pretty straightforward. Okay, so my point was, we're getting ahead of ourselves. We're going to say in the next exercise, say, what is the consumer going to choose? And we're going to combine together the preferences, the taste, with what they can afford. And we're going to say what the decision is to choose among all the affordable bundles, that is all the bundles in your budget set, the one that's most preferred. However, if we make the assumption of monotonicity, then the most preferred bundle must be on the budget line, not inside. Right? And you can see that. I just give you a few illustrations here. Right? Consider the bundle 2-2. Right? 2 movies cost $30, 2 pizzas cost $10, 30 plus 10 is 40. You haven't spent all your budget, so it's not on the budget line. It lies below it. The consumer, if they have monotonicity, if more is better, they would never choose 2-2. Right? Because they could always afford to say have 3-3 or 2-6. Right? And in fact, you know that everything to the northeast of bundle 2-2 will be preferred to bundle 2-2. And look at all these bundles here to the northeast of 2-2. All these bundles in this small triangle, they're all affordable. Right? They're affordable and they're preferred to 2-2. Right? So you know you would never choose 2-2. Right? That's true for any bundle that lies below the budget line. Alright? Pick any point below the budget line, there will always be points to the northeast that are affordable. And by monotonicity, since it's to the northeast, they're preferable, that means you'll never choose that bundle inside. Okay? So the upshot is, wherever you choose, you know it's going to be somewhere on the budget line. That makes our life easy. Right? Now, if monotonicity does not hold, then that's not necessarily true, as we're going to see later on. Okay? But the assumption of monotonicity is our standard assumption. More is better. If more is better, then you're always going to be somewhere on the budget line. You're going to be constrained by your budget. Right? You're going to say, you know, I wish I had a bit more income. I'd buy more because I actually like both goods. Right? If more is not better, then you may say, yeah, I have lots of income, but I'm just going to waste it away because I don't want to have more of the goods. They're not better for me. You know, I have enough. I'm good. Okay. So assumption of monotonicity says it's going to be on the budget line. All right. So let's take a look at the budget line. Right. So the next thing is, when we come to look at the consumer's choice, we only have to consider bundles on the budget line now. Makes our life easy, as long as monotonicity is true. Okay. Suppose you have income M, and the prices for good X is PX, the price of good Y is PY. Right? Good X, remember X you put on the horizontal axis, Y on the vertical. We want to get the equation for the budget line. Right? Well, remember, on the budget line, you spend your entire budget. So, if you take your expenditure on good X, which is the price of X times X, your expenditure on good Y, which is the price of Y times Y, add them together, that has to equal your income because you spent all of your income. Right? So it's exactly equality. Right? A more general case for the budget set, if you don't assume monotonicity, this would be less than or equal to. Right? But we're going to make it equal to. Making it equal to is going to make our life simpler. We have techniques, mathematical techniques to solve with what we call equality constraints, the equal sign. And they're easier to solve than the techniques that we have with inequality constraints, less than equal to. anybody has a dynamic programming background, you would have seen this, right? Does anybody know what, if you have inequality constraints, how you solve them? What do you call those? Method? Well, at least one method. Kuhn-Tucker method, I don't know if you've seen that. But the Kuhn-Tucker method can solve inequality constraints, but they're relatively difficult. We're not going to do this in this course. We're going to make our life easy. We're going to have equality constraints, and I'll show you how to solve equality constraints in general using what we call Lagrangians, which solve all nice and easy. And in fact, we're going to make it easier. In this particular example, I'm going to show you two conditions that have to be satisfied to find the optimal choice if we have equality constraints. So this is going to make our life easy. It's equality constraint rather than inequality. All right, so this is our equation for the budget line. Right? We spend all our expenditure on good X plus expenditure on good Y is exactly equal to our budget. Okay. Now I made life difficult. So totally differentiate the budget line, set the EM equals 0 because along the budget line your income hasn't changed, and then you can get the slope. Well, sometimes I overthink these things. It's a little bit easier to get the slope directly here if you don't like totally differentiating. Oops, I almost wrote on that with a pen. Okay. Right. Take this equation, the budget line equation, that tells you that Py times Y is equal to M minus Px times X. Right? I just moved the Px X to the right hand side. Now divide by Py. So Y is equal to M over Py, right? That's your vertical intercept, minus Px over Py times X. Should have changed that color to something else, but there you go. Okay. Right? That's a little bit easier, right? And you know from your high school math that the coefficient in front of the X is your slope. Right? It's a straight line. The vertical intercept is M over Py, and the slope is minus Px over Py. Okay? So that's a little bit easier than differentiating. All right? So the slope of the budget line is minus Px over Py. No surprise, because downward sloping, remember, prices are positive, unless it's told otherwise. And so minus the price is going to be negative. That's our downward sloping budget line. By the way, we call Px over Py the relative price of X. That is, X in terms of Y. I'll give you an example in a second. Right? It tells us how many Y you have to give up to get one more X. We'll see that in a second. Anyways, so there's our slope. We know the vertical intercept. We know the horizontal intercept. Right? The horizontal intercept is M over Px. The vertical intercept is M over Py. And now the slope is minus Px over Py. That's it. There's nothing else to that line. Right? The two intercepts and the slope, that completely defines your budget line. Okay. So in our example for the movies and pizzas, remember, movies cost $15, pizzas cost $5. So we know the slope of the budget line is minus 3. So I said the interpretation of this you can give is to notice that movies cost 3 times as much as a pizza. Right? That means if you watch one movie, you've given up 3 pizzas that you could have bought. Right? You spent $15 to watch that movie. You could have used that $15 to eat 3 pizzas. Right? So you had to give up 3 pizzas to watch one movie. Okay? That's what the interpretation of the slope of the budget line is telling you. The relative price of movies. PM over PP, how many pizzas do you have to give up to watch one more movie? Okay? And notice the distinction between the slope of the budget line and the slope of the indifference curve. Right? Remember, we take the minus signs of them. So the minus of the slope of the budget line is PM over PP. The minus of the slope of the indifference curve is MRS, just so we can make them positive numbers. Okay? So notice that the budget line, the relative price of movies, tells you what the market tells you have to give up to consume one more movie. You have to give up 3 pizzas to consume one more movie. MRS says what you're willing to give up. Okay? So imagine your MRS is 4. You say, I'm willing to give up 4 pizzas to get one more movie. And you go to the market, and the market says, you only have to give up 3 pizzas to get one more movie. Well, you say, that's a good deal for me. I'm going to give up 3 pizzas to get another movie, right? Because it's worth it to me. I was willing to give up 4, right? The market says I only have to give up 3. So if your market rate of substitution is greater than the relative price of the good, then you want to consume more of the good. You're willing to give up more than the market says you have to, so do it, right? Consume more of the good, okay? If your market rate of substitution is less, you're only willing to give up two pizzas to get one more movie. You go to the market and it says you have to give up 3 pizzas. You say, forget that, I'd rather eat pizza, right? In that case, you consume less movies, okay? So I just want to give you a feel for this. It's only when market rate of substitution equals to the relative price that you say, I'm happy. The market says I have to give up 3 pizzas to consume one more movie. I'm willing to give up 3 pizzas to consume one more movie. So I'm just as happy exactly where I am. I don't want to consume more or less. Okay? So just to get ahead of ourselves. All right. So let's see what it looks like here. Here's our budget line. But like I said, straight line, you can't get anything easier. There's only 3 things you need to know. What the intercept is, the horizontal intercept, m over pm, the vertical intercept, m over pp, and then the slope. Okay? We're done. Horizontal intercept is 4, the vertical intercept is 12, slope is -3. That's your budget line. Okay. Now, I want you to get a feel for the budget line. We're going to do what we call in economics comparative statics, which is just a fancy name that says we're going to take 2 equilibria, one before an event happens and one afterwards. So we're going to compare 2 equilibrium, and the equilibriums are static. We're not going to explain the dynamics of going from one point to another. All right, we're not engineers. Oh, hang on. Okay, so it's going to be static. We're going to start with one equilibrium. We're going to change something, say introduce a tax. We'll get a new equilibrium, and we want to compare those 2 equilibriums without saying how we got from one to the other. No dynamics. Right? So that's why it's comparative statics, comparing one equilibrium to another without worrying about the dynamics. Okay, so I want you to get a feel of when we do comparative statics, right, what's happening here. Suppose, for example, all prices double, including the price of your labor. So that means your income doubles. Your wages go up, double, just like your prices go up. So think of inflation. Inflation is 10%, all prices go up by 10%, including the price of your labor, your wages go up by 10%. Okay? So what happens to your budget line? Okay. So now the price of movies, everything doubled. Now the price of movies doubles to 30, the price of pizzas doubles to 10, but your income will double to 120. What's going to happen to your budget line? Right? Well, there's only 3 things to look at: the horizontal intercept, the vertical intercept, and the slope. Okay? Well, what happened to the slope? Well, the price of movies doubled, the price of pizzas doubled. So notice that the relative price is unchanged. It's still the case that movies are 3 times more expensive than pizzas. Instead of 15 to 5, now it's 30 to 10. But it's still 3 times more expensive. So nothing happened to the relative price of movie. Nothing happened to the slope of the budget line. What about the horizontal intercept? Well, remember the horizontal intercept is your real income in terms of movies. How many movies could you buy if you spent all your money on movies? Well, you have nominal income of $120. Movies cost $30. If you spent all your income on movies, you could buy 4. But that's exactly what you could buy before. The horizontal intercept hasn't changed. Right? You could buy 4 movies before. Now you can buy 4 movies again, at most. What about the vertical intercept? Same idea. You have $120. Pizzas cost $10 now. That means you could buy at most 12 pizzas. But that's what you could buy before. Right? So notice that the intercepts haven't changed, the slope hasn't changed. That means the budget line is exactly the same. Okay? This, by the way, is why you never, or I should say never, you rarely see inflation in microeconomics. We leave it to the macroeconomist. Right? To a microeconomist, we say, who cares about inflation? Right? If everything doubles, including your income, It doesn't change your affordable set at all, so it shouldn't change your rule. It shouldn't change your choice. Whatever you chose before, you have exactly the same problem now, you should choose the same thing. So for microeconomists, who cares about inflation? Okay? Now I will put a little asterisk on that when you get to grad school or something, right? Because what? Well, you're in grad school, I guess, so I will mention it here, right? So the asterisk is, there can be real effects of inflation, right? Ask somebody from Venezuela, what happens when there's hyperinflation? If it's really bad, then people divert their time and resources to trying to minimize the cost of inflation. So I talked to some people in Venezuela, what everybody does, they open up a banking account in Miami. That takes time and effort. You gotta send data, you gotta send information, open the account, pay for it, send your details, so on and so forth. And then whenever you get paid, you want to transfer it into US dollars in Miami as soon as you can, because your currency is depreciating so quickly. All right? That takes time, that takes effort. Or you get paid in your currency, you want to spend it as quick as possible before it becomes useless, so you run off to the market, right, looking for deals. I don't really need toilet paper, but I'll buy 500 rolls of toilet paper, right? Because otherwise my money's not going to be worth anything. I'm also get something for it. All right? You grab whatever you can. Right? The third one is, of course, in hyperinflation like that, often the shelves are empty, right? Because often what happens with hyperinflation, the government steps in and says, you can't charge that high of a price, right? So if you can't charge that high of a price, a lot of suppliers say, okay, I will supply it, right? It's not in the supermarket. Where do you get it? In the black market. Now you got to go to the black market, bargain, find the goods, and then bargain for it. These all take effort and time, right? So inflation does have real effects if it's really bad, like hyperinflation in Venezuela. For us, inflation of 1 to 2% is pretty much ignored, right? I don't know about you, but I don't say, oh my goodness, this is depreciated 1% per year. I better go and overspend it, right? I don't particularly worry about that. You probably don't either. Okay, so from a microeconomist point of view, we've nothing to see here, right? It doesn't change our budget set. Whatever was affordable before is affordable now. So whatever we decided to choose before, that's what we choose now. If it was most preferred before, it's most preferred now. Okay? So that part's easy. What happens if your income goes up? So this is a cateris paribus assumption. Your income doubles, but everything else is assumed to be the same. Right? So in particular, your prices are the same, but your income is double. Right? That's a nice situation, right? Same prices, but now you have a new job and pays you twice as much. Right? What happens to your budget line? What happened to the slope? Yeah. Right? We haven't changed the prices, so the slope hasn't changed. It's still the case that it costs 3 times as much to buy movies as pizzas. Right? What about the horizontal intercept? If you spent all your money on movies, because you have twice as much nominal income and the price of movies is the same, now you could buy twice as many movies. Instead of 4, you can buy 8. Likewise, if you spent all your money on pizzas, you could buy twice as many pizzas now, because the price of pizzas is the same, but your income is double. All right? So notice what happened to the budget line. The slope is the same, but the intercepts are double. Right? So what we have is a parallel shift out upwards of our budget line. Right? Same slope, but shifted up. Okay? By the way, if I do go too fast and you want to see something on the previous slide, just put your hand up and I'll go back and show you. Now, if you come in a half hour late and ask me, that's a different story. Okay, so what does it look like? Well, here's our old budget line. Remember, the horizontal intercept was 4, the real income in terms of movies. The vertical intercept was 12, the real income in terms of pizzas. right? And then the slope was -3. And we're saying the new budget line, when your income doubles, it's going to have the same slope, but you double the intercepts. So it's just a horizontal shift up to your budget line. Now clearly this is a good thing, right? As long as you have monotonicity, right? What was affordable before? Everything in this purple triangle. Now what's affordable? Everything in the green triangle, right? So the budgets, there were bundles that were not affordable before, they're now affordable. And in particular, with monotonicity, those bundles are going to make you better off. You guys will see. Okay? So that's a good situation to be in. That's the kind of deep thoughts you come for. More income is good. Okay. But that's what it looks like on a diagram. Okay. Horizontal intercept of 8, vertical intercept 24, but the same slope as before. All right, something a little bit more trickier, perhaps. What happens if the price of movies falls for $10? I'll give you a pair of this. Everything else stays the same. Okay. What's going to happen to our budget line? Up. Now, in this time, notice the slope changes. What happens to the slope? Is it steeper or flatter? You don't have to guess. I gave you the answer. I forgot to put that up already. All right. So notice before the price of movies was 15, the price of pizzas is 5. Now the price of movies is 10. The price of pizzas is 5. So we've gone from 15 over 5, which is 3, to 10 over 5, which is 2. Right. So the relative price of movies has gone down. Movies used to be 3 times more expensive than pizzas. Now they're only twice as expensive. Okay. If the relative price of movies goes down, that means that the slope of the curve is flatter. It used to be -3, now it's -2. So now we do have a change in the slope when you change your price. As long as both prices don't change, they don't both double or increase by the same percent or decrease by the same percent. What about the intercepts? If you spend all your money on movies, how many movies could you buy? Well, you have $60, movies cost $10, so you could buy 6 movies. So notice that the horizontal intercept has increased. It was 4 before, and now it's 6. Okay. What about the vertical intercept? Well, notice that your income hasn't changed, the price of pizzas hasn't changed, so the vertical intercept hasn't changed. You could buy 12 pizzas before if you spent all your money on pizzas. You could still buy 12 pizzas. Okay? So think about what happens here. The vertical intercept is the same, the horizontal intercept is higher, and the slope is flatter. So basically, the budget line just rotates out. So it looks something like the following. So when the price of movies fell from 15 to 10, the budget line rotates out. Same vertical intercept, higher horizontal intercept, and the slope is flatter. Notice if you're comparing the budget sets, the old budget set is the purple triangle. The new budget set is the red triangle. Notice the red triangle completely encapsulates the purple one plus a bit more. There are some bundles here that were not affordable before, but are now affordable. Okay? So it may be that whatever you chose at the old price is not going to be what you're going to choose at the new price, because now there's some bundles that you couldn't afford before that now you can afford, and maybe you like that new bundle is better than the bundle you chose before. Okay? So it is possible that you will change. Likewise, to go backwards here. Here, all these bundles were not affordable before, but are now. So what you chose originally on your budget line, right, is not what you're going to choose now. right? You're going to choose something on the new budget line over here. All right? So your choice will change as your income changes or as the price of the good changes, or can change. It may stay the same. Okay? But at least it potentially can change because the budget, the set of affordable bundles has changed. It's increased here. Okay. I'm not going to go through these ones, but just test your knowledge and make sure you understand how budget lines change when you change the data, right? The parameters. So what happens to the budget line if your income goes down? What happens to your budget line if the price of movies, instead of decreasing, increases? What happens to the budget line if the price of pizza decreases? If the price of pizza increases? Right? So just play around with that. Make sure you understand how to manipulate the budget line, just so you have a feel for this. Okay. Now I want to do two other cases. That's the budget line that we're going to use day to day. Okay? But there can be other budget lines as well. I just want to let you know that there may be other conditions besides that you have to spend all your income. Right? That the expenditure on X plus expenditure on Y is equal to your income. There could be other constraints as well. I want to introduce one that's rather apropos to today, to nowadays, and that is if you're reading the newspaper or whatever, reading online, you know that there's rationing of toilet paper in a lot of supermarkets, right? A limit, I don't know what the limit is, but that's what we call rationing. There's a maximum amount that you can have, right? So in this example, we're going to keep it like we did before. You have $60 in income, movies cost $15, pizzas cost $5, but there's a limit on 9 pizzas. Okay? You're not allowed to buy more than 9 pizzas. This is the health board saying more than 9 pizzas is too unhealthy, right? You're not allowed to order more than 9. Okay? How would that change your budget line? What's it going to look like now? Any idea? Yeah. I thought you did.
It's gonna. I feel like the budget line will be the same, but like it's just there's gonna be like a vertical line or a horizontal line based on the term constraints, like how much you can get.
So where's the horizontal line then?
Like maximum 9 pizzas. Yeah.
Right.
Just the horizontal at pizza equal 9.
Yeah. And
the budget line.
Right.
Line would be unchanged.
yeah. So they're going to be where?
The ration line and the budget line.
Where would they be? What bundle would those two lines be? What's that? Yeah. Like if you bought 9 pizzas, that cost you $45. You have $15 left over. You can buy one movie. All right. So your budget line looks like you said, the old budget line, except that once you hit 9, you can't have any more. Right. So now your second constraint kicks in. All right. And the kink is at the budget 19. Right. If you have 9 pizzas, you can have 1 movie. Okay. So that's what your budget line will look like. So it is possible for the budget line to look different. Okay. And there's an example with rationing. Okay. The second example I just want to show you, because we can talk a little bit about this later on. We've been assuming, of course, that you can consume fractional amounts. What if you can't? What if you say, I just want to be a bit more realistic and say you can only consume whole amounts. You can't watch 2/3 of a movie. You could, but you have to take the whole thing. Right? So it's not possible to buy 2/3 of a movie. Right? So if we do whole amounts, what happens? Well, now your budget set, the affordable bundles, are just going to be those points. Right? The white parts, they don't exist. You can't buy a half a movie. Right? You can't buy, or you could buy a half pizza, but suppose you're not selling a half pizzas. Right? So if you want to have discrete X and Y, then you're just going to have points in space rather than the whole space. Okay? And now you can see the budget line. It's pretty much the same idea, right? You can have horizontal intercept, vertical intercept. Doesn't quite have a slope because it's not actually a line, it's just a series of points. Right? You can't consume in between because those are fractional amounts. But you can sort of see a line there. Okay? So why don't we do this? Well, because we're lazy as economists, we like using calculus. Right? And if this discrete, you can't use calculus. All right? Now, modern day, of course, with computers, doing discrete analysis is much easier. Let the computer do it. Right? So if you've been seeing, in the last decades, discrete mathematics is becoming much bigger. And so it is possible to solve these types of problems. What's the most affordable bundle, right, among all the discrete bundles? But in this course, we're going to have continuous differentiable functions, so we can use calculus. Okay? I just want to give you a feel for it. Now, I will give an example to motivate quasi-linear preferences. I'll start off by using the discrete case, just to motivate it. But in general, we're going to use continuous cases. Okay. So I told you the affordable set part is easy, right? A straight line. You can't get any easier than that. Okay, for the rest of this week, hopefully I can do this set of lecture notes. Well, we put the two together. We have our taste. We know it's affordable. Put the two together and find what the consumer is going to choose. So given their preferences, their tastes, which we represent visually by difference curves, or algebraically, mathematically by utility functions, and then also given the budget constraint, the budget line, or any other constraints we have in there. All right. In economics, we assume rationality. However, the assumption of rationality in economics doesn't mean what it means in day-to-day stuff. So when we say you're rational, all we mean is that among all your affordable bundles, choose the one you like the best. That doesn't seem too controversial. But that's what we mean by rationality. Okay? So let me be careful about this. Imagine there's two phones. Okay? And one's black, and the other one's identical, except that it's red. And the red one costs $50 more than the black one. And you decide to buy the red one. And someone says, that's irrational. It's the same thing, same phone, it's just a different color. You pay $50 more. There's nothing irrational about that. If you like red better than black, that's your taste. Okay? If that's your most preferred bundle and you can afford it, right? Fine. Okay? So what we mean by rational is not that you're some kind of logical computer and looking for, I want to buy my groceries by how much and the cheapest way of getting all my calories. Right? That's only the rational way of doing it. No. You can blow all your money on an expensive vacation, or you can spend your money buying lottery tickets. There's nothing irrational if that's what you like. Again, as economists, right, no disputing taste. Your tastes are your tastes, right? All we ask is, give you a ranking from most preferred to least preferred among all the affordable bundles that you choose the most preferred. That's all we mean by rationality. Okay? So it doesn't mean what it means outside of economics. Okay? Now, putting this in terms of our preferences, that means we really only need the first two assumptions we talked about. Completeness and transitivity. Now think about why is that the case. Remember, completeness says, for any two bundles, we have to be able to say that either you prefer A to B, or you prefer B to A, or you're indifferent between the two. Okay? That is, you should be able to know your taste, what you like, right? If you don't know which ones you prefer, how are you going to choose the most preferred one? Right? So we need completeness. Right? If you don't have complete preferences, then how can you choose the most preferred bundle if you don't know you prefer it? Okay? So we need completeness. Secondly, we need transitivity. Right? Remember, transitivity says that if A is preferred to B, and B is preferred to C, then A is preferred to C. We said if you don't have transitivity, the problem is you can get cycling. Right? A is preferred to B is preferred to C, the C is preferred to A, which is preferred to B, which is preferred to, and you just go around and around and around, and there's no best. Right? You can't say which one's most preferred if you violate transitivity. You just keep on cycling and say, I can't decide. A is better than B, but B is better than C, and C is better than A. And you just go around and around and around. Okay? So we need that, complete transitive preferences. That's what we mean by rationality here. As long as you complete transitive preferences, then you can say, okay, I know what my most preferred affordable bundle is. Okay? And therefore we need that you choose that bundle. Okay? Now the other assumptions we've talked about are either reasonable assumptions or assumptions for convenience. Right? So we said it makes sense to assume monotonicity. You like to consume more of the good. We don't need that for the rationality for you to be able to choose the most preferred bundle. Right? Imagine that you don't have monotonicity. Maybe the good is the bad. You can still choose your most preferred bundle. You don't need monotonicity to make that choice. You can say, you know what? That's bad. I don't want any of it. Right? You can make your choice and say, this is my most preferred bundle that's affordable. That's fine. We only need these two to be rational. Right? So monotonicity is a reasonable assumption we add in, but it's not necessary for rationality. Again, continuity, as I showed you to the discrete case, the problem with the discrete case is changes calculus. So we usually assume continuity and then we go further and assume differentiability, so we can use calculus. And by the way, continuity, even if you don't have differentiability, continuity is very useful. There's lots of properties that mathematicians have developed for continuous functions. So for example, you may be familiar with Weierstrass's theorem. It says if you have a continuous function defined over a compact set, and I won't bother defining a compact set here, although the budget set is a compact set. If you have a continuous function over a compact set, then that function will attain a maximum and minimum on that set. Right? So if we have a utility and difference curve, if our difference curve is continuous, so the utility function is continuous, given that our budget set is compact, and we're defining it, then it turns out there will be a maximum. So it will be a most preferred bundle. Right? So there's something we can take from mathematics about continuity that we can say, yeah, the maximum exists. And that's good, because we want to talk about what the maximum is. What's the most preferred bundle? Right? That'd be pretty bad if we start doing it without knowing it doesn't exist. Okay? So I'm just saying that we make these assumptions because they're so useful. Right? Strict convexity, we'll see where that comes in useful as well. But the only ones we need for rationality are the first two. Okay. All right, so let's see how we solve the consumer's problem. Okay? So the consumer's problem is, among all the affordable bundles, which one is most preferred? Which one will you choose? Okay? So let's have two goods, X and Y. Right? The consumer has utility function, UXY, and a budget line, PXX plus PYY equals N. So the consumer's problem, in terms of indifference curves, we would say, choose the affordable bundle that's on the highest indifference curve. Right? Find a bundle that's affordable, but also the most preferred bundle, so it's got to be on the highest indifference curve. In terms of the utility functions, that says you want to maximize utility subject to the budget constraint. Right? You have a budget constraint, in particular the budget line. Of all the bundles on the budget line, which one maximizes utility? Right? Maximum utility is the highest utility. Remember, higher difference curve have higher utility. Right? That's how we define the utility function. Okay. Okay. So we're going to work on both of these. All right. So here's what it looks like visually. Here's our budget set. We said, right? The horizontal intercept. You take the income divided by the price of what is on the horizontal axis. Here the movie, 60 divided by 15 is 4. The vertical intercept, 60 divided by 5 is 12. The slope minus 3. Right, we have a budget line in the budget set, below it, on and below. And here's what a choice looks like. Right? Here's all a bunch of indifference curves. We have to choose an affordable bundle, that is a bundle in the budget set. And we want to choose the most preferred affordable bundle. And we see that's at the bundle 2-6, right? Because that's the highest indifference curve we can reach among all the affordable bundles. Notice that we actually prefer the green bundle, right? By monotonicity, further away you are from the origin, the more preferred it is. We actually prefer the green bundle, but notice it's not affordable. It's not in the budget set. Okay? Notice that the red bundle is affordable, 2 movies, 2 pizzas, but it's not the most preferred bundle. It lies on the lower indifference curve. Okay? The most affordable bundle, so among all the affordable bundles, 2-6 is the most preferred affordable bundle. Now notice I've drawn the indifference curves as strictly convex. That makes our life a little bit simpler here. If the indifference curve is strictly convex, notice what's true at the most preferred affordable bundle. Right? At the most preferred affordable bundle, there's 2 properties that are true. One is that that bundle is on the budget line. We knew that already. With monotonicity, you're going to choose a bundle on the line, not inside the line. Right? So that's the first property of the most preferred affordable bundle, is it's on the budget line. The second property, as long as you have strictly convex difference curves, is that the slope of the budget line at the most preferred affordable bundle is the same as the slope of the budget line. Right? That is, the budget line is just tangent to the indifference curve at the solution. Okay? So we're going to make use of that to find the most affordable bundle. We're going to say, whatever the affordable bundle is, it must satisfy 2 properties. It must be on the budget line, and the slope of the indifference curve is equal to the slope of the budget line at that point. And that will allow us to find the bundle. Okay? Now you can see why strict convexity is helpful here. Okay? We'll look at that later on. All right, so solution to the consumer's problem. As I said, there's 2 properties going to need to be satisfied. Right? X star, Y star is a solution to the consumer's problem. That is the most preferred affordable bundle. Has to be on the budget line, and the slope of the indifference curve is equal to the slope of the budget line. But remember, the negative of the slope of the indifference curve is margin rate of substitution. The negative slope of the budget line is the relative price of Px or Py. So our second condition is the margin rate of substitution is equal to the relative price of X. Okay? How much you're willing to give up for the good is exactly equal to how much the market says you have to give up, as we talked about earlier. Right? The market says you have to give up 3 pizzas to get another movie. You choose a bundle where your margin rate of substitution is also 3. You're willing to give up 3 pizzas to get another movie. Right? So those are our 2 conditions. So basically what you have here, I give you, or whatever, you're given the data, you're given the prices, and you're given the income. So the only thing you have left here is the x's, and the margin rate of substitution will have the x's in the x, y, and be function of x and y. So basically you have 2 equations, 2 unknowns solved. Right? Now I'll show you one way to solve. If you like to use a matrices, you can solve with matrices as well. And in fact, like if you have, say, 4 or 5 goods, right, then you're going to have more equations. You probably want to put them in a matrix and let the computer invert it and solve them. Right? But for two goods, 2 equations, we can solve it by hand. Right? If you have more than 2 goods, matrix algebra is a good way of solving it. Okay, so let's see how we would solve this on 2 goods. Okay, the method is 2 conditions have to be true. 1, margin rate of substitution has to equal to the relative price. Right? So set those equal and get one variable as a function of the other variable. What we mean by that is put one of the variables on the left-hand side and everything else on the right-hand side. So get y as a function of x, or get x as a function of y. If you get y as a function of x, then substitute for y into the budget line. where you see the y in the budget line, put the function instead. Right? So you eliminate the y, and now your budget line only has x's in it. One equation, one unknown, x, you can solve out. Okay? So you solve for x. Once you get x, plug it into your function, and you can solve out for y. It's easy to see this with an example. It doesn't go. The only thing I will mention is sometimes you'll find it easier, instead of step one and getting y by itself on the left-hand side and x is on the right-hand side, you might want to get x on the left-hand side with all the other stuff on the right-hand side. X is a function of y rather than y is a function of x. Whatever, it doesn't really matter. Whatever way is easier, do that. Basically, you have two equations, two unknowns. Solve however you like. This is typically how we solve it. Okay, let me give you an example. So here's our utility function we had from last week. It's a Cobb-Douglas utility function. Our utility is equal to x raised to some exponent 2/5 times y raised to exponent 3/5. Okay. Last week we found out we calculated the margin rate of substitution. We said the margin rate of substitution is equal to 2y over 3x. Basically, the numerator is the exponent on x, the denominator is the exponent on y, 2/5 divided by 3/5 is 2/3. Anyways, the margin rate of substitution, what we found last week, was 2y over 3x. Right? So our problem becomes easy. Set that equal to the relative price. Right? Suppose the price of x is 10, the price of y is 5, and you have an income of 50. Right? Notice I have to give you this. This is given to you. Right? So we set the margin rate of substitution equal to the relative price, and we solve. So when I say we solve, I mean you solve. Okay? And then I'll show you my solution. So try that out. Find the optimal bundle. You want to see the margin rate of substitution again? There it is. Oh, I meant to make a poll everywhere about this for your answer. Okay, so how much X and Y will the consumer choose? Anybody have an answer? Is that? Yeah. Okay. So 2 and 6. Let's find out how to do that. So hopefully you find it straightforward. So we set the margin rate of substitution equal to the relative place. So 2y over 3x is equal to 2. Solve out for y, we got y is equal to 3x. Or you could solve out for x and get x equal to y over 3. So y is a function of x, or x is a function of y. By the way, before I go on to solve this, just to give you a feel for this, when you look at this, notice what it's saying. Whatever the optimal bundle is, right, what's going to maximize the consumer's utility, that is the most preferred bundle that's affordable, is going to be where you consume 3 times as much y as x. Y is 3 times x. Can anybody give me a feel for why do you want this consumer want to consume more y than x? There's 2 reasons here. What's one reason? Why would you want to consume more y than x? Okay. Notice that x is twice as expensive as y. That's one reason you might want to consume more y than x. So you know what? Y is pretty expensive. I think I'll consume x. Sorry, x is pretty expensive. I think I'll consume y. You know, x is $10, y is only $5. Right? So one of the things that influence your decision, of course, is going to be the relative price. What's the other thing that informs your decision what to consume? And that's your taste. Take a look at your taste. Notice you have x raised to the power of 2/5, but y is raised to the power of 3/5. Y gives you more enjoyment than x. Not for every amount, but you can see that if you have 1 unit of x and 2 units of y, you'd be happier than you would be with 2 units of x and 1 unit of y. Right? Plug those numbers in and calculate the utility, and you'll see that. Right? So there's 2 forces here are acting on the consumer to consume more y. On the one hand, all else being equal, they like y more than x. And secondly, y is cheaper than x. Right? So both of those are sort of pushing you in the direction of consuming more y. Notice they could go in the opposite direction. You like y more than x, all else being equal, but maybe y is more expensive than x. Imagine when y costs $10 and x costs $5. For that reason, you want to consume less y. So they're sort of battling out. What's the final answer depends on the strength of those 2 forces. Okay? So I just want to give you a feel for this. Why it's showing the way it's showing up here. Right? If you reverse those 2/5, 3/5, right, this wouldn't be as strong. It still may be positive, still may be more. I don't know. Try it out. But it may be less. Okay? I mean, it still may be more than x, but it's going to be less than 3x. Anyways, so that's the first step. You said margin rate of substitution equal to the relative price. That tells you whatever the equilibrium is, whatever your most preferred bundle is, at that most preferred bundle, you're going to consume 3 times more y than x. What's the actual bundle? Well, we take that and we plug it into the budget line. Right? So 10x plus 5y is equal to 50 is our budget line. Right? Remember, the price of x is 10, the price of y is 5. So we replace the y with 3x. So now we just get one equation with one unknown. 25x is equal to 50, so x is equal to 2. If x equals 2, plug it back into here, we see that y is equal to 6. Okay? Now notice 2 equations, 2 unknowns, it's easy to solve this. Like I said, if you had 3 equations or 3 equations and 3 unknowns, 4 equations and 4 and so on and so forth, you'd be better off using matrix algebra. But for the 2 good case, this is what it is. Okay. Okay, so we conclude, therefore, that if the consumer has a budget of, oh, by the way, you want to be extra careful. I don't know how careful you want to be. Make sure you got the right answer. If you plug in the answer 2.6 into your budget line, check that uses up all your income. 2 times 10 is 20. 5 times 6 is 30. Yes, that uses all your income. It's on your budget line. You could also check, by the way, that the margin rate of substitution equals relative price. What's the margin rate of substitution at your most preferred bundle? Well, y is 6, x is 2, so we have 12 in the numerator, 6 in the denominator. 12 divided by 6 is 2. That equals the relative price 10 over 5. Right? So at the most preferred bundle, the margin rate of substitution does indeed equal the relative price, as we say. Right? Okay. So we conclude that's our method for finding the most preferred affordable bundle, right? Set the market rate substitution equal to the relative price Px over Py, and then make sure it's on the budget line. Pxx plus Pyy is equal to M. Okay. That's our methodology. I think I'll leave this for Wednesday. I'll show you the cases where this breaks down. Now, I will give you away the thing at the very end, right now. As a default position, assume this method works. So if you've got to solve something, assume that you can use this method unless told otherwise. So unless I say, hey, you can't use that method, it won't work. Okay? Assume you can. Okay? Just to let you know. I'll show you the Chamber of Horrors on Wednesday, all the cases where that method breaks down. Okay? Take care.
This might be a bit hanging my mind. Is just I know this might sound a bit weird, but I was thinking. I'm thinking, what if the machine is just a bit? And now we have two points. My opinion thinks this is I want to go with this one, although this is not the highest but now we have two options.
Wait, we had all these options. Alright?
So like this is
So this is your budget set, right? You can choose any of these. Right? You can have any of these. Whatever you like. Yeah, that one. So you could have this one. You can't have both of them. You only spend one bundle together. It's a low, you'll be worse off.
So I can still use it?
You could, it's affordable, yes, you could, but you wouldn't choose it, right? Yeah.
So if this is it,
You choose one.
like here.
Yeah, then you know it's on the lower end difference curve, so it's less preferred. Well, why would you choose it? Right? You could have this one or this one. You told me by your preferences that you like this one better than that one. So it would be that would be irrational for you to choose one. They're both affordable, and if you chose that one, that would be irrational because it's not the most preferred.
Oh, is this thinking if I, I think I see exactly. So if I shift this to just a bit to left.
Yeah.
So because there exists another interference curve just lower than that, right? Then this would give me two intersections.
Be careful. You can't choose both of those.
Oh, I have one.
Right? Well, each one uses all your budget. Right? You can't choose both bundles.
Oh,
Right?
I see.
That bundle uses all your income because it's on the budget line.
But still, it gives me two options. I should.
You had those options. All those options were available before. You can only pick one.
Okay.
Right? So so the fact that those two are available, you could pick them. You can't have both of them. You can't say I want 2 and 6 and 6 and 2.
Yeah.
Right? Because 2 and 6 is using up all your budget.
Yeah.
Right?
And
And
then
so is 6 and 2.
One more question.
Yeah, no problem.
Sorry, it's just a bit. So in the last lecture, so we had that 2 bottle of waters, and then
Yeah.
we wanted to derive the utility function, it was just simply x1 plus x2. My question is, based on the definition of the utility function, we came up with this, was it because of rule of sum that we wanted either 1 or 2, or was it just because the total matters?
Yeah, total matter. Now, the actual form I used, remember there's no unique utility function.
Yeah,
I could have taken this and
definite,
squared it. That would also be a utility function. It'll give you the same preferences.
Yeah, okay.
All we're changing is the number we put on it. So if we call the square d, it's the same thing, x1 plus x2, but I square it. Okay? Now this bundle here, 1, 1, sorry, better than pick 1, 1, 2, 2, right, would have utility here of 4, right?
Yeah.
Here would be 16.
Yeah.
All I'm doing is saying this number is 4, but if I use the v function, the number is 16. I'm just relabeling the indifference curves, but nothing's changed for the indifference curves. You know, it's not real, right? So yeah, if you notice what I say is, it can be represented by this utility function. There's lots of them you can use, right? Since all he cares about is the total amount of water, that'd be fun. Now, if you
We
took a,
expect it to, based on our text, or let's say you write something,
Yeah.
should we get the utility function based on the definition, or
some of them,
some of them?
easy ones.
Easy
So
one.
if you take a look
It
at
can
this
be a bit
week's,
tricky.
yeah, so if you look at this week's tutorial,
Uh-huh.
I think I do Tom with between 2
I
bottles.
looked at the
Yeah, so one's a 250 milliliter bottle of water, and the other one's 500. Okay, and all he cares about is the total amount of water. So I asked you to give me a utility function that represent that. Okay.
Oh, okay.
Now it's not going to be just the sum of these two because you're
It
not
should
a
be
different.
coefficient of 1 plus the, like 2 of that.
That's what you have to figure out.
Yeah,
so
okay.
those are kind of relatively easy cases I'll give you. I won't say, I don't know,
Yeah.
something, x squared plus y squared over, I'll give you that. If it's a square kind of thing, I'll give you that function. But simple ones like this, just to play with your mind. Look at this week's tutorial.
Okay, sure. Thanks.
Sure.
Cheers.
Cheers.
One more question.
Sure.
Oh, yes. So when we wrote, so when we were changing either of these parameters, like for the budget set, so like the way they were rotating out, so like one time changed, so we were changing the slope.
Yeah, I'll be right there in a second. Just
No, all good.
organizing my mess. Okay, yeah. Yeah.
Yeah, so like was 1 minus 3 and 1 minus 2.
Yeah.
So when we say the slope is minus 3, this means we're willing to give up 3 of this for 1 of this.
If it's -3, yeah.
And when it's 2, so although we are changing the slope of budget set, but we are changing the indifference curve as well because we're giving up less.
No. This is the slope of the budget line tells you how much the market says you have to give up. Your indifference curve, the margin rate substitution, is what you're willing.
Yeah.
Okay? The indifference curves are fixed. They're always the same. So you have a set of indifference curves. That's your taste. They don't move around. Now we can label them different because the utility function is not unique. I can give you these different numbers, but they always look exactly the same. That's your taste. That's you.
Yeah.
Okay? That's who you are. Now what can change are your circumstances. I can give you this amount of income and prices, or I can change the prices.
Oh, so
You
it's
see what I
just
mean?
defining that area of mutual area. Of
Yeah, affordable bundles.
Okay. Okay.
Yeah, so that can vary. Your tastes are the same.
Okay.
Like your tastes are given. That's just basically a piece of data. It's stable. It looks like that, right? We're not allowing you to change your taste of,
Yeah.
right?
Sure.
You've developed your taste. This is who you are. Okay. What we are changing are prices and income.
Yeah.
That's what economists are considering.
Okay. Okay. Now
We lost the bottom of this.
No, it's this.
Oh, you got it.
Yeah. Sorry. No, just. All good.
Good. So where you from? Or
Sorry.
where you from?
Oh, originally I'm from Iran.
Is that right? Eh?
Yeah, Persian, but
Is
yeah.
anybody sick back there? You know?
No, not yet.
Okay.
Like yeah, so I think, yeah, it's just a bit of they don't have the integrity to give us the real news of what's going on in Iran.
Right.
So yeah.
Oh, you live here permanently now?
Yeah, yeah.
Yeah.
But, yeah, like for me it's a bit different because I grew up in Italy for like 8 years.
Oh yeah, that's also lockdown.
Yeah, so wherever I go, Australia should be very.
Yeah, we're worried about you.
Yeah.
We'll put you on an island somewhere.
Yeah, but so far, so good in Iran. Yeah. I mean, it's just like messed up. So let's see how it goes.
Yeah, I know an Iranian from. He was in grad school at La Trobe named Reza.
Reza, very common name.
Yeah.
If you go to infrastructure building, most of them Persian. So if you randomly say Reza, 2 or 3 people.
Well, like John here, right?
It's just very common name. Reza, Ali, Amir.
Right.
These are just like very common Persian names.
So you say where in Persia are you from?
So Tehran, the capital.
Saffron? Or Tehran?
Tehran. Yeah, it's the capital.
Yeah.
So my brother also lives here. He's a citizen and he's also doing. So he's a lecturer now.
Yeah. In what?
In DCAN, in software engineering, cybersecurity. So that's why I chose Australia. He was here and then he said just come along.
Yeah.
Yeah, and my parents were like, okay, go at least to one continent. Then spread.
Spread it out. I'm originally from Canada, but the weather's nicer here.
Yeah, Canada is I was thinking to do PhD in Canada, but recently I just got this job here in Melbourne. So I'm still I don't think.
What kind of engineering? Mechanical?
I'm a mechanical. I'm doing mechanical with business.
Right.
So
good.
So far, let's see how it goes.
Yeah.
But I like Vancouver. My best friends
Yeah.
are all in Vancouver, and I like mountains and stuff because Tehran is also
Yeah,
like that.
yeah.
So
I would imagine you used to snow as well in Tehran.
skiing is just my favorite thing. But here, I like Melbourne as well. I don't like very hot, humid like Sydney.
Yes.
I can't stand it.
Yeah,
I
no.
really can't stand it. I'm also like a jumper. I just like snowy stuff.
I know it's so easy. It's so easy here.
But
although if you talk to people from Queensland,
they
think Melbourne's really cold. Right? How can you live down there?
No, I can't wait for winter to go to hot springs. It's just
by the way, we'll be recorded.
really okay.
I just start with that.
Okay, sorry people.
Yeah.
Yeah.
Okay. All right. I'll see you on Wednesday.
See ya.
Cheers.